Pre-calculus video on the inverse unit circle. So up to this point, we have already discussed in lesson 4.7 our inverse trig functions, and we've looked at the graph of the sine and cosine inverse functions, and also at tangent as well. But I kind of want to go over how the inverse unit circle is going to work for us, and then also in the hopes of us memorizing our values so we can go backwards, and so we can easily find the inverse trig functions for certain angles. So let's just do a little review here. For our different quadrants, remember, of our unit circle, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 1, we know the signs of both coordinates are going to be positive. In quadrant 2, our x values are negative and the y values are positive. Quadrant 3, both are negative. And then in quadrant 4, we have a positive x and a negative y. These are going to be important for us because we know that when we're working with our inverse trig functions, when we looked at the graphs, we had to make sure that we limited the domain of our equation so we can actually make them a function. Remember, a function must be one-to-one, which means that every x has exactly one y value. And so in order for us to actually have that inverse function, we have to make sure that we limit our domain so we can actually not pass that horizontal line test. Let's do a little review here in this case. When we're looking at the inverse sine function, we know that the sine curve is going to keep on repeating. So we looked at this graph before, but if we look at the inverse sine function here, we notice that it has a domain of -1 to 1. That's because on the unit circle, our sine values are going to start at 0 and go up to a max of 1 at 90 degrees, come back down to 0 at 180, and then reach a minimum there at 270 degrees at -1, and then we come back around, and they just keep on oscillating between those values. So that means here that we need to make sure that we limit our domain, because since this is the sine inverse, the range and the domain are switched. And so our range here will be the domain of the original that we limited from -π/2 to +π/2. So we know that the domain has to be from -1 to 1, and the range is -π/2 to +π/2. So if we think about our unit circle, and we know that our domain is going to be -1 to 1, and our range is -π/2 to π/2, that means that we must restrict sine to just quadrants 1 and 4. In particular here, that we have to be in quadrant 1 because that's where we have the positive y values, our positive sine values. But then we want to go backwards. We're going to rotate clockwise to the fourth quadrant so we can get the negative y values. And we're going to see that here in just a sec, but it's kind of like we're taking that first quadrant and just flipping it over the x-axis so we get those negative y values. We could possibly use other quadrants here if we wanted, but we're sticking with quadrants 1 and 4 in order for us to actually make sure that we get the smallest radian values possible, because they're the easiest ones to work with. And so if we were to start here, let's just go ahead and start by filling out since we're working in quadrants 1 and quadrants 4, we know that we have our angles. So let's go ahead and put in our quadrantal angles at 0, 0, and π/2, and 0, 1. And then we can put in our 30 degrees and fill out just the rest of that first quadrant. We know at 30 degrees we get coordinates square root 3/2, comma 1/2. 45 degrees or π/4 radians is square root 2/2, square root 2/2. And then 60 degrees is π/3 radians, which is 1/2 square root 3/2. It's going to be very important for us if you need to take a chance to go back and look at your unit circle. We really need to make sure that we have these coordinates memorized, because we need to make sure that we can easily go back and denote what we're talking about here when we're trying to evaluate these trig functions. But we notice here that we have all positive y values, which are our sine values. So going from 0, 1/2, square root 2/2, square root 3/2, and 1. And so we can go ahead and flip that over the x-axis to our quadrant 4, and we're going to get the negative angles. So notice we're going to be using -30 or -π/6, -π/4, -π/3, and -π/2. Yes, these would be coterminal angles with the other angles that we usually are used to, so like the 270, 300, and so on. But since we're going backwards, we're going clockwise here, we want to make sure that we're getting those negative values. So we're going to use that quadrant 4, and so that way we don't have to skip quadrant 2 and skip quadrant 3. Mathematicians just go ahead and assume that these are going to be the easiest ones to work with, and so we're going to stick with them as well. And so if we think here, these will give us our coordinates that we're used to, but really we're just going to be focusing on those y values because those are our sines. So we get the negative 1/2, the negative square root 2 over 2, negative square root 3 over 2, and the negative 1. And so these all right here are going to be our values that we want to make sure that we are able to use when working backwards with our inverse sine function. So for example, if I want to know the sine inverse of positive 1/2, well then that's going to be pi over 6 radians, because pi over 6 radians has our y coordinate of 1/2. Similarly, if I wanted to find sine inverse of negative 1, well in that case I know if I am using my inverse unit circle, that, I have a y value, a sine value of negative 1, where I'm working with the angle of negative pi over 2 radians. And so by having these quadrants memorized and knowing these coordinates, it can really help us easily evaluate these inverse trig functions. One thing that we should know here is that these same coordinates or quadrants that we use for sine are also what we're going to use for tangent, because we've looked at the tangent graph before and we see that it starts repeating itself at one period between negative pi over 2 and positive pi over 2. We'll look at that here just in a sec though. Let's talk about cosine for a sec. The cosine graph is going to be very similar to, or one that we've worked with before, but we know it's just offset by pi over 2. And so for the cosine inverse function, it's going to have a restricted domain between 0 and pi. That means we're going to be working in just quadrants 1 and quadrants 2. So it's going to be a little bit different than the sine graph because we're sticking to those positive ones there. So let's go ahead and still work with our first quadrant, which will be quadrant 1, in quadrant 2. And so if I go ahead and label my angles again, I have 0, 0 radians. My coordinates, my other quadrantal, 90 pi over 2, 0, 1. I'm going to go ahead and do my 180 in pi, which is at negative 1 and 0. So again, we're getting that range here, going to be between that 0, or so not range, that domain between 0 and pi. So I'm going to go ahead and fill in my quadrant 1 angles. So I get 30, 45, and 60, pi over 6, pi over 4, pi over 3. And if I fill in their coordinates, I still get that square root 3 over 2, comma 1/2, square root 2 over 2, square root 2 over 2, and then 1/2 square root 3 over 2. In this case, though, we're just going to be working with the x values because that's our cosine. So we see that if I had had cosine inverse of 1, that would be 0. If I had cosine inverse of square root 3 over 2, that would be my 30 degrees. So it's asking, hey, which angle has an x value of the value that we're working with? In this case, though, instead of flipping over the x-axis, we need to make sure that we have a negative x value. So that means we're going to be flipping over the y-axis. So this is why we're going to use quadrant 2 here. And so we still have those angles and degrees of 120, 135, 150. Oops, I labeled that one wrong. Let me go ahead and fix that. So then I get 2 pi over 3 radians, 3 pi over 4 radians, and 5 pi over 6 radians. And then I can go ahead and fill in those coordinates, and it's just going to be those exact same coordinates flipped over, but I now have my negative x value, so my negative cosines, because I need to make sure that I'm going between a range value of 1 and negative 1. And so I still have those x values. So unlike sine and tangent, which were for quadrants 1 and then quadrant 4, this is just for cosine, we need to have those x values, so it's going to be quadrant 1 and quadrant 2. Yes, we could find the coterminal angles and use quadrants 3 and 4 if we wanted, but again, since quadrants 1 and 2 have the smallest radian values, smallest positive radian values, I should say, we want to use those to help us because they're the easiest to work with. So like I mentioned, tangent is very similar to sine. They work in the exact same quadrants. So we see here that for the horizontal line test shows that the tangent function is not 1-to-1. That's unless we go ahead and limit it to a certain domain. And so that means that tangent inverse is going to be the reverse of that. And so it's going to have a restricted domain of between negative pi over 2 and pi over 2. Note here it does not include these values because we have those asymptotes on the tangent function. So they're not going to be brackets here, it's going to be parentheses because they're not actually going to be included. So this means, again, that we'll be working in quadrants 1 and 4. And so what we want to do next here is kind of do a review and think about, hey, how do I actually find the tangent of a function? What we're going to talk about next year, you do not need to memorize, but it would be kind of nice just to see in practice. So if you want to look at it here, let's just do a little review. All right, I'm going to go and fill in my unit circle first. Hopefully you already have yours in front of you, but I'm going to fill in quadrants 1 and 2 for us here. Again, we're using the negative values here for the radians because I want to make sure that I'm using the negative y values. And I want to keep my angles as small as possible. So that means we're just going to flip over the x-axis once again. So that's why I'm getting that negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. I'm going to go ahead and fill in my sine coordinates, my y values in red here, so we can see those that we've talked about before. And then I'm also going to go ahead and then fill in my cosine values in blue, because those are my x values that we've seen before. Remember, cosine is going to still use quadrant 1, but in this case, since we're just using quadrants 1 and 4, I'm just going to go ahead and flip those. There's going to be the exact same x values because they're not changing here at all, since we're all on that positive right side of the x-axis. So for tangent, remember, tangent of an angle theta is always found by taking the y-coordinate over the x, or we can also think of that as the sine of the angle divided by cosine of the angle. And so if I were just to go ahead and do these for the first quadrant, let's just start with 0. So we know tangent of 0 is going to be equal to 0 over 1, or just 0. Tangent of pi over 6, positive, is going to be that square root 3 over 2 divided by 1/2. But remember, dividing by a fraction is the same thing as multiplying by the reciprocal. So that's going to give me square root 3 over 2 times 2 over 1, which simplifies to a positive square root 3. I can do the same thing for our pi over 4 angle. And when we take square root 2 over 2 divided by square root 2 over 2, well, that's just going to give us a positive 1. For pi over 3, I'm going to take that 1/2 divided by square root 3 over 2. And if I go ahead and simplify that and go ahead and do my keep, change, flip, and also rationalize the denominator, I'm going to get square root 3 over 3 for my tangent. And then finally for my pi over 2, I will see that it's going to be undefined because it's 1 divided by 0, which is just proving to us a fact, again, that I can't be at pi over 2 because I'm going to be undefined. So that's why I have the parentheses there. So all this is saying here is that if I'm asked to find tan inverse of positive 1, I don't know tangent right off just from the coordinates. But what I'm trying to ask myself here is, hey, which angle on the unit circle would give me a value of 1 if I took the y-coordinate divided by the x-coordinate? In that case, that's going to be at pi over 4. And so this is how our inverse trig unit circle can actually help us here if we kind of see these values and know what we're looking for here. So I know, like, if I'm looking for, tan inverse of 0, I'd be like, well, that's just going to be my 0-degree angle. If I know that tan inverse of square root 3 is my pi over 6 angle, that's just a nice, easy reference for us to do, so I don't have to do that division of y over x every single time. The nice thing about this is it's also going to work for quadrant 4 because all it's going to do is change the signs of our tangent values. So for negative pi over 6, I get a tangent value of negative square root 3. For the tan of negative pi over 4, I get negative 1. Tangent of negative pi over 3 is negative square root 3 over 3. And then tangent of negative pi over 2 is still undefined. So it's just going to be that reverse here, but making those negative. So I still can use my basic angles that I'm used to, but it's just going to have a negative value. So if I'm asked to find, the tan inverse of negative 1, it's a negative 1 this time. That means I have to be working in quadrant 4, not quadrant 1, because those are my only two options. And so that means that if I'm working in quadrant 4, then that means that it's going to be the angle measure of negative pi over 4. So by having these values memorized and practicing using them and just actually seeing them, I don't have to reference my unit circle every time. And it's also nice for us to know which quadrants we're going to be limited to.